Alright guys, David Choi here. In this video, we're going to be discussing my new open source project. It's my first open source project called SurrealDB Client, and it is a driver, a client driver for the database SurrealDB. In this video, we are going to be making queries, inserts, updates, all that good stuff into SurrealDB, but the main focus point of the video is more the Rust code and how I built this project, and a little bit less on the SurrealDB part. But very quickly, for those who are new to SurrealDB, SurrealDB is a database that internally is structured like MongoDB, so it's a JSON document store. But externally, as far as the developer is concerned, it uses about 80-90% standard SQL. So you kind of get the best of both worlds. You're able to do all your queries in the familiar SQL syntax, but you get the performance benefits and the schema flexibility of a document-based data store. So that's what we're going to do. Let's get started. All right, so the first thing we need to do is get set up. So you want to be running an instance of SurrealDB somewhere that you can call into, obviously. So I am just taking their script from their website and running a Docker instance, but I'm having a username and password in there, and we're going to be sending that when we make the actual queries. And then in terms of the dependencies that we're going to be using, how do I explain this? So asynchronous functions within traits is not available within the language yet. So we need to make use of this crate. Since we're using Tokyo, some of the returns on the functions and related types will come from these two guys. There is this thing called OneCell, which allows you to effectively lazy load certain heavy objects one time as needed, and therefore not having to load it again. I'm using that for some of the fixtures on some of the integration tests. And then we have SurD. SurD is what we're going to be using for JSON serialization. And then there are a bunch of types that are part of the querying mechanism. So things like object, the type object, statement, etc., etc. So I am importing those from the default SurrealDB database project itself. And then this is a mechanism to kind of simplify error type creation. And then we have our Tokyo runtime. Again, all of the asynchrony is coming from the Tokyo package itself. It's not part of the core language. And then you have the non-asynchronous tungstenite for WebSockets. And then you have the asynchronous WebSockets called Tokyo Tungstenite. So then this will be used to pass into Tungstenite, creating a URL, and then some UUID generation for unique IDs. So let's start taking a look at the code. And I'll break down the structure first so that it makes more sense. So as you can see here, we have the source folder. We'll talk about examples and tests in a bit, but you can break down this driver basically into two main pieces. So we have the actual connection and everything related to making a connection. And then we have the driver itself, which is where all the calls to sign in, use a namespace, make a query, all that good stuff would exist in. So the main file for the connection is this file right here. So then if we start from the top, and I'm going to just assume most of you guys are not that familiar with Rust, but So we have a struct, and this is one of the types where data will go into. You can also have enums and tuples and related structures. So SurrealWS connection. So what are these fields? Every request that you make to SurrealDB is going to have some sort of unique ID. So I create a globally shared within an instance of SurrealWS connection. I create a globally shared last request ID, and every time I make a new request, I just update that ID. This probably isn't the best because I don't really need to do this, but this actually started as an integer because a lot of the structure and the patterns I got off of the SurrealDB Java driver. So for now, I'll just keep this. But so why do I need these types in here? So we are using Tokyo Tungstenite for making WebSockets connections, and Tokyo Tungstenite uses Tokyo, and internally Tokyo is based on the reactor pattern, a lot like how Node works, and it uses an event loop and all that stuff. But unlike Node, Tokyo is multi-threaded with a thread pool. So you do need to, when you're making async calls, you do need to lock shared resources. So from the left, we have this atomic reference count. This means that it's protected against multiple threads simultaneously accessing the data and corrupting the data. But if you do that, then you need some sort of lock. We could have used the mutex lock, but the mutex lock is a global lock for both read and write. So I decided that the read-write lock, which is separating the locks of reading and writing, would be a little bit more performant. So that's why I'm using that. And then you have the UUID, which of course is a unique ID generated randomly. So then use TLS. Am I using encryption or not? Yes or no. Currently in this alpha of this driver, I am not, but eventually I'll turn that on. And then we have host, port. So these two guys are the main way that we will be sending requests to the WebSockets, therefore to Surreal. And then getting the responses back would be the reader. So this is sort of kind of analogous to having the request and response in Node. So what is this? In Rust, the data itself is decoupled from the member functions and associated functions. So in order to create functions associated to a certain instance of SurrealWS connection, we have to implement SurrealWS connection and put the functions in there. So the first function is a function that will create an instance of the connection. And this is just an idiomatic pattern. This is how most instances are going to be created, across the board, whether it's this or some other struct or enum or whatever. We have similar type parameters as the fields in our struct. And then this capital S self means give me back the same self type as the one that this function is being constructed in. And then in here, we have an instance of the actual connection, which looks a lot like an object literal. But this is a return statement because there is no semicolon. And it's the last statement. I mean, currently it's the only statement. But anything that is the last statement inside of a function scope that doesn't have the semicolon in the end just implicitly indicates return. So then here we have again a new atomic reference count. it's locked by a new RW lock, and then we have a new UUID value. So then this is where I guess a lot of people have problems. I definitely had problems when I was learning Rust. So we have this function. We have, it's an async function. So this async keyword and the way that async functions work inside of Rust is actually extremely similar to the way async works in ECMAScript, so ES6 and beyond. So just like in JavaScript functions, you have an async function, and it actually uses promises internally and all that good stuff. You have something akin to that in async functions in Rust, where async functions in Rust internally are returning a future, and then inside of the future you have this whatever the real type that you want to return. So the future in Rust is analogous to the promise in JavaScript. So then we come to this parameter right here. So before I move on, I need to explain this. And you can skip ahead if you're already familiar with how memory management in Rust works. But if you're not, and we try to go through the code together, you're just going to be totally lost. So I think I need to explain this a bit. So in Rust, you do not manage, even though it's a systems language and there is no garbage collector, you do not manage memory directly yourself. So you don't, in other words, you don't call delete or drop or whatever and clean up the memory manually yourself in code. The memory is going to be cleaned up automatically depending on whether you're using reference counted memory or the ownership type of memory. But in general, at a high level, once the immediate parent scope ends, then that memory is going to be automatically collected. However, having said that, it's not that simple. So explained at a high level, there's really two types of memory management in Rust. The first one, and the main one that even if you're kind of new to Rust, you've probably seen before, is the ownership and borrowing type of memory management. And that's the type that we're using in here. And then the other one is reference counted memory management. And super quick, reference counted memory simply means that you can borrow, you can share as much as you want, but every time a new borrow or a new share occurs, meaning a new reference occurs, there is a count in the runtime for this data of exactly how many references are have been taken out, like how many are outstanding. So let's assume that there's 10. And as each reference count, as each reference goes out of scope, if we pretend that this is a function or some other higher level scope, but as each reference goes out of scope, then that reference count will be decremented by 1. So it becomes 9, then 8, 7, 6, 5, until it reaches 0, then the memory gets collected. So at a high level, that's how ARC, RC, etc., those systems work. The ownership and borrowing mechanism is a little bit more complicated. And basically the way those work is, since this is a parameter to the function, right? And it doesn't really matter that it's, the instance of the object itself. It could be a reference of, some other thing, right? Some other thing. But either way, we know that at some time earlier, this thing, whatever it may be, as long as it's a reference, right? So we're talking about specifically references. We're not talking about value types, copy types. So if I say the thing and then whatever it is, I instantiated it here, blah, 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 right? This variable right here is the owner of the data, right? And that simply means that when this thing, the owner of the data, goes out of scope, again, if we pretend that we're in some other scope and then the scope ends right here, then that's when this memory becomes invalid and gets set up for collection, right? Irrespective of who is borrowing, who is later borrowing the thing and what's going on there, assuming that this hits the end of life because its immediate parent scope has ended, then that's when the memory is going to get collected. So then how does sharing of references, that is sharing of this data without actually owning it, how does that work? So let's separate out mutability from sharing, just to be clear. So here you can see that I have a mutable reference, right? So just to be clear, mutability is distinct from borrowing, okay? So in Rust, they try to be as safe as possible. So if you want to declare a thing and then change it sometime later, then you always have to be very explicit about that, and therefore you have to indicate that you're intending to change it eventually, right? So a lot of things like that are explicit inside of Rust. And we're just having these errors here because I'm doing it outside of any function call. And like I said, the fields themselves are going to be in the parent struct or enum. But anyway, so just to be clear, this is a distinct thing from the sharing of data. Now, if I want to share the thing, then it's called borrowing. And then the syntax or the key word that I use is the ampersand to indicate that I'm sharing. And then if I want to share, but I want to share it also mutably, then I have to indicate that I'm getting a reference, but I'm trying to get it mutably, right? The other thing to know is that the mutable references there can only ever be one mutable reference. And when there is a mutable reference, so as soon as I declare I cannot have either any more read-only references or mutable references. However, I can have multiple read-only references at the same time. So let's get rid of that. So then the next question might be, why not just either do this and send the own self in, or the mutable own self in, or the non-mutable own self in? So the reason why we can't do that is because, as I mentioned before, the memory management model is based on who is owning the memory. So if I pass in the object not as a borrow, but the object itself, the data itself, then the ownership is changing hands, and the ownership is now falling inside of this scope right here. In other words, the function scope. But the problem with the function scope is, of course, that eventually it ends. So if I were to do this, whether I did, non-mutable or mutable, if I were to do this, once the function scope ends, then this memory is no longer valid. And then subsequent to the connect call, I cannot actually call self dot whatever, or whatever the variable name of this instance is. I can't call that anymore because it's invalid as it's been collected now, because this scope just ended. Of course, it is possible for me to pass it in and then pass it back out, right? So that is possible and valid to do. But then it starts affecting the method's signature. And, if I do it across the board, then I don't think it's particularly idiomatic. I haven't seen that kind of function calling much, and then it also makes this very busy as well. So we're going to keep it as a borrowed mutable. So then the next question might be, well, why does it have to be mutable? Well, it has to be mutable because my intention is that after I make a connection, that eventually I'm going to set up the reader and the writer instances, because eventually, the intention is, of course, to send some messages to SurrealDB and accept responses. So I need to be able to mutate the instance of the object. Okay, so from the top again, we have our connect async. So this is Tungstenite again, but it's the asynchronous Tokyo-based version. So we have to await it at the end. So again, this is a lot like JavaScript. So in that sense, it should be pretty easy to understand. And then we need a URL, of course, to Tungstenite itself. This means non-encrypted. This means encrypted. And then we check that field whether we're using encryption or not. And then, of course, we have self host and self port. And this indicates that should something go wrong in the attempt to make a connection, then I want to have some sort of my own custom error that is returned, which I haven't populated. But, eventually I'll put something in there. So then let's take a look at this syntax. So in Rust, there is, if you know Swift, there is a lot of like syntax to do guarding, like you're trying to protect against things being null and stuff like that. In Rust, there are similar structures. So this is an enum called option, and one of the variants inside of it. This is the way that you do nullability, sort of in Rust. So in Rust, you don't have true nullability. You can't set something as null. So what you do instead is you use an enum, again called option, and then you indicate that either there is some data of some kind, and then of course you pass in whatever that data is, or you indicate that there's none at all, right? But again, it's not null, so you can't really throw an exception by accidentally calling that. So this is a safer mechanism than having nullability, and that's why it's in the language. Now, the reason why the let variable creation indicator is here is because you actually are creating a variable, and you're simultaneously checking that whatever is on the right-hand side is not none or not null. And then if it isn't, then this variable will be created and the real data inside of it will be accessible. as you can see here. In this case, it's an error, but of course, you can put in whatever data you need to put in there. I'm just doing a print line, but what I'm returning, that is, I'm escaping out of this function because it's not in a valid state, right? I didn't get the desired response, which is a valid connection to SurrealDB. So I just want to exit right away, but I want to indicate why I'm exiting, what happened. So I'm sending this error, and there is no throwing of exceptions because there is no exceptions in Rust. So you're just returning objects and dealing with error objects for error handling in Rust. So just super quick, these are the errors that I have custom. They're specific to the connector. When we get to the driver, we're going to be using the errors as they come in from SurrealDB. So that would be that. But as you notice, it's an enum. And then internally, we have all these different case variants. And then we're using this error to be able to have our custom messages per each error type. And that's why this is here. So assuming we get past any failures and we're able to make a connection, then we want to get the underlying socket itself, right? So how do we get it? Well, like I said, when we have a situation where something could return either a null, or in this case, something could return either a valid response or a failure of some kind, right? We need to deal with that. We need to write code that handles that situation, right? So there's multiple ways of doing it, and this way isn't always the most recommended, because if you try to unwrap, and unwrap means give me, the valid data, and you try to unwrap, but what happened is that it returned an error because just like option, this is an enum. So internally, it has the valid data variant, right? And then if it failed, then it has the error variant, right? So if you were expecting it to have the data proper and then it came back with the error instead, and you attempted to do an unwrap, then this thing would panic and the function would fail. So this isn't the best way to handle result types, but I'm doing it here because I'm assuming that if I pass this error check, then everything is good to go. So I should be able to unwrap and get the underlying, real data that I want without issue. So as long as you're handling your errors correctly, or you're in a situation where it's highly unlikely that an error will occur, this is an acceptable thing to do. So then we have our actual WebSocket, right? Now, inside of the WebSocket, again, we have a reader and we have a writer, and we're trying to access those. And by the way, this structure that you see here with the parentheses is just a tuple. And a tuple is, of course, unnamed types, multiple types inside a single object construct, right? So in here, we have a tuple, and we decide to give them some names just to be clear. So we have reader and writer, and then we access the tuples in here by splitting the single WebSockets object and giving us the tuple. So once we are ready to write, again, because this field type writer in our object instance is an option type, we need to select the appropriate variant to use. So since we do have data, we're going to use sum, and we're going to pass it in, and we're going to use reader sum, and we're going to pass it into reader. And then if we've reached this point, everything was successful. So we can send a result that is of type OK, but in this case, there's nothing in it. It's a unit type, which is an empty type. So then that means that we're returning result : OK unit type when we return this. Whereas if we had an error, we would be returning error, ERR, indicating error, and then the specific type of error inside of it. All right, so that was slow going, but there was a lot that I think I needed to explain, so things should progress much faster now. So we don't need to explain this. We already got through that, and then the result type. So we're going to do a disconnect here when we're ready, so we don't waste connections to the server and waste resources. The ability to close is unintuitively inside of the writer. So we are going to get the writer from the instance. We're going to close it, and then this is an asynchronous call, so we're doing a wait on it. There are two types of doing sharing. We can do the borrow type with the reference indicator, but we can also do borrows via code. There is something called borrow, and there is something called borrow mutably, and then there is, as you can see, as mutable, but there is also as ref as well. So these are, we haven't seen this yet, but very quickly, there are structures called traits inside of Rust. And these traits are, how should I say, very similar to interfaces, except they're not inheritable, as there is no inheritance in Rust. So just like interfaces, you have, they're actually more like abstract classes. But again, they're not inheritable because you can have implemented functions in them. But the syntax is very similar to doing an impl on the actual struct or enum. But basically, it allows you to create a sort of empty structure if you want to. Again, implementations are allowed, but most of the time you're going to create just method signatures in there. And then the implementer, right? The implementer is going to implement the function. If this were one of the functions inside of a trait, then it would implement that function to do whatever was appropriate to your needs. So this as ref is a trait, and borrow is also a trait, but they have different requirements, but they effectively get the same thing, which is a reference, either a non-mutable reference or a mutable reference. So in this case, close is needing a mutable reference, right? So that's why I do the call to as mute first, and then I unwrap it, right? And then I call close, and then I call await. Now you might say, well, mutable reference is here already, but mutable reference is indicating this guy right here, right? We never marked, if you look up here, we never marked this as a mutable reference, right? And neither did we do that for reader. So this call close is actually coming off of writer. It's not coming off of self. So we need to indicate that we want writer as a mutable reference, and we do that right there. And then this is an optional. As you can see right here, it's an optional. So we need to unwrap it. There's other ways to get at the data, but right now we're doing unwrap it because I feel that it's safe. I know that this is gonna, be set up because of this call right here. So I feel safe in unwrapping, and then I close and I await on it because this is an async call. All right. So the meat and potatoes, the heart of the connection object is, ooh, I didn't clean this up. If you see this in the source code, just ignore it. This is something I need to remove. So this is the RPC caller, remote procedure caller, for doing any and all of the calls that are going to SurrealDB. So select, insert, update, create, delete, blah, blah, blah. Everything that we need to call is always going to enter in through this function and do its thing, and be sent out to SurrealDB, and then the response will be gathered and then retrieved and sent out. So let's explain from the very top the signature. And some of this is also involving how SurrealDB works. So if you're intending to use SurrealDB, which I think is a pretty awesome database, this is going to be helpful for you. So any call that you make into SurrealDB has to have an indication of what type of call or what type of statement that you are making. So are you pinging? Are you asking for info? Are you trying to set up the namespace, the name of the database, stuff like that? Are you trying to sign in? Are you trying to do a query, right? So again, we have an enum here. I am creating a member function. In this case, what I'm doing is a match statement in Rust is a switch statement. It's the same thing as a switch statement. And in this case, because this is the enum itself, we're trying to look at that enum and see which of its variants came in, right? So then switch statements in Rust are exhaustive, meaning you have to have every single case indicated in your match statement, or else it won't compile. One thing you can do if you don't want to handle every case explicitly, you can use this global handler and then do whatever you need to in there, right? If you have only one main variant that you want to deal with and everything else, let's say you want to do a print line or something to that effect, you can do that. But in my case, I have a specific thing that I want to return for each variant, and that would be a string name for the method, right? Which is because that's what SurrealDB is expecting in the call itself. And as I said before, if it is the last statement and you don't have the return keyword and the semicolon, it means that you're returning. So then if we go back, the next thing that we have is a list of parameters that we're going to be sending to SurrealDB. Now, this will make more sense if I show you this document. So SurrealDB has a specific sort of schema for the way of calling into it. So this document right here is going to give you a high-level overview of what is expected. So you can see here all of the different types of methods that you can make a request for. And then over here, you can see the different types of parameters and what expectations each parameter type might have. So in our case, we're going to be doing a lot of heavy querying. So a query is constructed of two things: a string representing the query itself, and then the arguments that might be an array of arguments that might be in the query. So arguments means like dollar company name, dollar first name, stuff like that. So if we go back to the RPC params that we had here, right? So because we could send in various types of parameters, because like I said, that RPC function is supposed to be handling, you know, the entire universe of possible requests to SurrealDB. This RPC params is an enum, and then I will have more eventually, but currently I have the type specific to the calls that I am making to SurrealDB. So some of these are coming from the SurrealDB project itself. I'm getting those types directly from them because I didn't want to, you know, reconstruct all this type structure because it's quite heavy over there. So I figured I'd just reuse theirs. And then the big one that you want to concern yourself, because 99% of the time you're going to be querying, right, is the query type, which is, again, a string statement of what your query is, and then the actual arguments that you might be passing. It's also possible not to pass any arguments and just have a string statement with maybe the arguments already in there. And we'll see that once we start querying. So then inside of this, we also have the RPC request, which is the data structure that we ultimately pass into our write, self.write, that calls into SurrealDB. So like I said before, an ID to indicate the unique ID of the RPC request, and then the method itself, which could be query, sign in, you know, use, etc., and then the set of parameters that are going in there. All right, so again, the idiomatic way of creating an instance, we pass those parameters in, we get the same type as self, and we're done. So I'm going to come back to this in a little bit, but let's go back to our function. So we want to take the method, and then we want to call our conversion function, right? So we can get a string instead of the actual enum variant, which is Rust specific, right? So then we use last request, and as I mentioned before, we have a lock on it, read write lock. So in order to get a write lock, which allows writability, we have to make a write request and await on it, because there's multiple threads that could be either having the write lock or first in line. And then we can take that, we can dereference it, right? Meaning we can say, okay, I don't want the reference, I want the actual data itself. And that's what we're doing right there with the little asterisk symbol. And then we set it to the new UUID, and then we pass it in later and use it later. Now, like I said before, I started out using an int, and that's why this is still here. I'll probably clean this up because we don't actually need this, but I'll do it later. Okay, so we're gonna make a request. So we need to build our RPC request object. So we take our unique ID of the request, we take the method type, the type of request we're making, and then we pass in the parameters. And then we come to this guy right here, which requires an implementation. So serialize is coming from a crate called SurrealDB, and SurrealDB provides various serialization facilities, not just for JSON, but for, byte arrays and all sorts of things. So in order to indicate that we will be calling serialize and how we want our data to be serialized, we have to implement it. So that's what this is about. But as I mentioned before, when I was talking about traits, serialize is a trait within SurrealDB, the SurrealDB crate, for providing functionality without necessarily providing implementation. So in this case, we are providing the implementation for this function, right? So implement serialize for RPC request. So then we come here, the usual parameters in here. This is pretty obvious what it is. This is a constraint. So it's a generic constraint on whatever types that we are deciding to use in the function. In this case, it's indicating that the S type must be from the SurrealDB serializer. So then if we come here, we're indicating, okay, what type of thing am I trying to serialize, right? So in this case, RPC request is a struct. So, So I want to serialize a struct. What is the name of the struct? RPC request. And then I give the size of the of an RPC request. And then on top of that, so I get this mutable state object. So then on top of that, I want to indicate each of the fields, right? So I give the name, and then I give the field itself, that is the value of the field itself. And then I have to finish the serialization, so I end right here. So let's just undo that. So then now I have my JSON object, but just like any complicated action, this action might fail or this action might succeed, right? So if it succeeds, then I get a string back, and if it fails, then I get an error back. In this case, I'm basically positive because I implemented this function, right? So I'm basically positive that the serialization was successful. So I just go ahead and hard unwrap it, and then I get a string, which is what Surreal is expecting when I try to write to it. So just to kind of be fully clear about possible sends, you don't have to send text like I did. Depending on whatever you're trying to do, you can send binary data, you can ping it, you can do all sorts of things. In our case, obviously that doesn't really make sense, so we're sending the JSON over because we're trying to query, so that's why we're sending JSON, and that's why we're sending the text variant of message. And by the way, this message type is coming from Tungstenite, because that's the WebSockets capability that we're using. So then over here, we have this very strange thing. Loop is exactly what you think. It's just an infinite loop that you have to manually break out of if you're going to exit. This is part of the Tokyo runtime. Again, asynchrony in Rust isn't built in directly to the language, although I do think it's coming eventually. So we're using this Tokyo runtime to get certain facilities from it. In this case, we're getting a macro, and this macro is simply allowing multiple calls to be made in an asynchronous manner, but only using the very first call to return. So in this case, I just need a quick way to make an async call. I didn't want to make multiple, so I just took this effectively as a wrapper type for asynchrony, and that's why I'm using this. So internally, what am I doing in the call itself, right? So what I'm doing is I'm making a next iterative call. So what does that mean? I have a reader that I got from the WebSockets, right? This is a server, and these functions are asynchronous. So that means that at any time, the reader could receive the next piece of data to receive, right? So I am making that request, saying, give me back the immediate next piece of data, right? And then stick it into opt message, right? So again, we have a match statement, a switch statement in Rust, and then we're going to see, what we get back. If we get back data, meaning successful data, then we're just going to return it, which is of type result message or error. And then if we don't, then we're just going to break out of this loop right here. And then we're going to give or return back a custom error message, basically. Now that I look at this again, probably should have made this an ERR, but that's okay. We'll fix that later. So that is effectively, all of the stuff that we actually need inside of the connection. So although I took a lot of time to explain things because I wanted everybody to be on the same page, it's actually, if you look at it, it isn't all that much code. It's pretty bare bones, but we need this baseline to be able to actually make the connection and do the requests to Surreal. So here, we just have a bunch of tests. You feel free. This is a public repository. It's an open source project. So feel free to go in here, try out the tests, mess around with them, blah, blah, blah. But these are the tests as of right now. And then if we go into the driver itself, and as I was saying before, the driver simply means that it's going to take that connection, right, that live connection, and then it's going to provide the facilities to make all the various types of calls into SurrealDB. So ping, info, sign in if you have a username and password, use the thing that sets the namespace and the database name. And then in this case, because I haven't finished this project yet, we have the custom query function only right now, but it's not limited because this custom query function can accept any query statement. So the insert, the update, the create, select, delete, creation of relationships, all that stuff. So the functions that I need to build out are really just helpers to make it faster and easier to, call select or call insert or whatever. So even right now, you can make, live calls into SurrealDB of just about any query type that you want to do. So if we go from the top, here, this is a very long type that I'm using. So I just create a type alias. So our struct is Surreal driver, and it only has a member data type of Surreal WS connection. And then again, idiomatically, we create an instance of Surreal driver, and we pass in this connection, and then we set it to itself. We have disconnect capability. I'll show you the code that's actually calling this driver a little bit later, but let's just go through these functions. So pinging, I'm trying to see, you know, hey Surreal, are you up? Are you on? Are you available? So I send in the instance of Surreal driver. I make a connection. I call the connection object, and then I make an RPC call. The method or type of call that I'm making is a ping. In the case of a ping, I don't actually need any parameters at all. So that's why this empty objects thing is here. And then, of course, I wait on it, and then that's that. So the other stuff, I'm not really going to get into other than... Actually, I should explain this. So if you look at sign in, you see that this is pretty much straightforward. Here, I am actually passing in arguments into the query itself. And that would be the username and the password, and this is how Surreal expects it. So in this case, we have a B-tree map, which is kind of like a dictionary thing. So then we have the string, and then we have the value. Into is a conversion caller. So I'm taking password, I'm taking username, which are of type string slice, and then I'm converting them into some other type. In this case, I'm converting them into this type because that's what I explicitly annotated right here. But obviously, you know, you can implement this trait and return whatever type you need to do the conversion from whatever type you have to whatever type you want. So here, as I mentioned before when I was explaining RPC params, let's just go back to it. We have different types of params that we can potentially enter. And then here we have the objects type, the variant of objects type. And then we're passing in those B-tree arguments as an object, and then we're making the call. So same thing here, I won't explain that. And then in the case of an actual query, we have the query itself, the query string itself. And again, we're going to take a look at that. And then we are going to, let's see here. So we have the query type that I'm indicating. We have the query parameters. In this case, the string itself, and then the list of arguments, which again is a dictionary style type of string and string. So then let's take a look at how to call these. So in Rust, if you want to do integration tests as opposed to unit tests, generally unit tests are going to be in here. For now, these are actually live integration tests. They're not unit tests, but I'll be mocking these and updating them eventually. But normally when you want to do integration tests, you put in a folder called tests into the root of your project, and you will have individual test files in the root of tests. As you can see in my test cases, I have some additional structures in here. So I have a fixtures, which I'm not entirely using yet. But if you've done testing before, you know, this is where like a lot of the instances of various things that you might need up front are going to be instantiated and made available, and then you can just reuse them in your actual test. And we'll get into this stuff as we go through the tests. So the first test that So the first test that I have is driver ping succeeds, right? So again, we're using Tokyo, and these tests are asynchronous because we're making asynchronous calls inside of the function. So we can't do Rust, test indicator. So we have to use Tokyo once again, and then we have to indicate that it's a test, and then that's how the runtime realizes that this is a test, such that when you use cargo on the command line to run test, as opposed to cargo run, which runs the actual project. In this case, this is a library, so there's nothing to run. But if it was having main.rs, then we could run it. And if we wanted to run it, we would use run. But if we only want to run the test, then we use test. So if I run it right now, so it ran all of the tests, including the tests inside of the SurrealWS Connect file, as well as the integration tests. So as I was saying, this is the first test. And the way that I've broken up these tests so that they don't overlap and they don't cause problems, because I'm running off of, because like I said, this is an integration test, so it's a live hitting of the database, and I didn't want to, have tests conflicting with data and stuff like that. So I'm using this setup function, and I'm creating a new namespace every single time for each of the tests, right? And then I call my driver, and I do the ping call, and then I do some sort of assert, and then I clean up at the end. So the way that I've set these up is I am passing in a new namespace and a new database name, and then in the end, I've set up an instance of Surreal driver. So if we look at, just for the purposes of seeing how to make calls to all of these entities, so I'm creating a new instance of SurrealWS connection, and then I have it and it's mutable, and then I make a connection to the database and I await on it, so everything suspends until I get an actual connection, because obviously I don't want to try and do stuff before the connection is live. And then by the way, this indicates that something is being returned, but I don't care about it. So that's what that's about. So then here we have our new connection, and then we have our driver instance that is created. And again, it's mutable because a lot of these calls need mutability on the instance of the driver. And then I sign in because in my case, I'm having a username and password. So I have to sign in. I indicate a new namespace and database to use. Oh, my scroll is very crazy. So I indicate the arguments because this is a query as well. So oh, sorry. This is where I do cleanup. Sorry. So I pass in I create arguments to indicate which namespace I'm referring to, and then this query right here is to remove the namespace, and this $ns is the name of the argument inside of SurrealDB. So I'm passing in that argument here, and then we await. And we're done. We've created our instances. We've cleaned up any prior data for this specific namespace, and then we can return our driver. And then here we're just doing a cleanup. So this is more for the end. And as you can see, I disconnect at the end just to minimize resource usage. And so we have that. We have that. All right. I think this is probably more, yeah, this is probably more realistic of a call. So as you can see by the test name, we have driver relation creation of employee to company succeeds. So in this test, I'm trying to create an employee that has an association or a link to the company. So the way that I'm doing that is, I do all my setup stuff. So again, I need to sign in. This is redundant. I think this is because I didn't do cleanup of this function, but that's okay. So the actual first query that we need to do is we need to create our data set, right? If I'm building a relationship, I need to have a company that exists to begin with, right? So I'm doing what is actually a multi-statement query because Surreal enables that. So as you can see by the semicolons in each line, there are two queries in here. This stuff right here is Rust syntax for string literals, where I want to format it so it's more readable instead of having all of this stuff on one giant line. So this indicates that it's basically like a new line call, and then it indicates that there's more strings to come. So in the first case, I am making a call that's called create. So this isn't standard syntax, it's specific to Surreal, but I make the create call. I'm creating an entity called company. I am setting its name field to super big corporation, and then that's that. Now, the cool thing is, because SurrealDB is a JSON document store, it's a dynamic schema, right? I can opt into pre-created schemas if I want to, but why do that? It's like, then why use SurrealDB, right? So this syntax will, if this database table doesn't exist, it will create it. If this field doesn't exist, it will add it. So then if another company had already been created, let's say called Acme, and then I ran this call subsequent to that, and let's say that when I had created Acme, the only field inside of company was name, but then I decided that, okay, I'm going to add another field like second, whatever, right? I can do that because the schemas are built up dynamically and it doesn't fail, there's no errors, and there's nothing wrong with doing that. So that's a really awesome, convenient feature for why you might want to use SurrealDB. So we have our company that I want to make a relationship to. And of course, we need an employee just to get things going. So we have create employee, and the employee has a first name and a last name, and that's it. So in this case, we're not sending over any arguments. So I have this empty B tree because it's a required argument. And then again, in this case, I don't care about the return because I know that this is valid syntax and it's going to work. So then I wanted to show not only the create, but then after, subsequent to creating, that I can basically create again, but with the standard SQL syntax of insert, right? So again, we have our driver.query, and then we have insert into what? Into company, right? And which fields am I going to be modifying? Well, I'm going to be modifying only name, and then the value is going to be Acme. And again, I'm not actually passing in any arguments. I have the argument directly in the query itself. So that's why this is empty. And then I make that call and I'm done. All right. So here things get a little bit busier, so let's go through this. Let's move this out of the way. So in this case, I want to select the company, right, that I'm going to create my relationship for. And the reason why I want to do that is because I want to get the company's ID so that I can insert that into the the related field in my employee. So the way I'm doing that is, in this case, I'm actually creating arguments because I want to pass that in. So there is a argument called co_name, and its value is going to be Acme. And I'm converting these into strings because that's what btree_map is expecting on the query. And then I make my query call where I select everything from company, and then I say where the name is equal to that co_name argument, right, indicated by the $sign. And I'm passing in the arguments btree_map to indicate that. And then I get this list, I get this result, which is of type message or error. This is going to succeed, so I just deal with it. But internally, in order to keep this code smaller and tighter and reusable, I did what what we all end up doing whenever we're dealing with databases is conversion methods to take the data type that's coming from the database and then convert it into the type that is actually usable within our own context and language and platform. So in this case, I'm saying, obviously, hey, from the result message, give me the other thing that I want, or the other type that I want, which in this case is RPC response, which I think we already went over, but maybe we didn't. Oh, okay, I'll go over that again. But so I'm taking the message in. Again, I don't want ownership because I don't want this thing to die, after the function ends. So I'm taking a borrowed reference. So I get that message. And then in this case, we have the other type of guard that is new to, I believe it's Rust 1.65. So in this case, the syntax means I'm assuming this is successful, meaning that message actually is a successful result and therefore gives me back the data that I want, which would be indicated by this. But if it's not successful, then I'm going to return empty. I'm going to return none, which is indicated by this thing right here, right? So assuming that we don't hit this piece of code, we just continue moving forward, and subsequent down here, that means that this message object is available for us to use. So because this message is of type enum, we have to extract the underlying data, right? Meaning we have to deal with the variance inside of the enum itself. So in this case, we have what I know is going to be the variant, which is message text. And then that variant is going to have a payload of whatever the JSON string is, meaning whatever the JSON string coming back from SurrealDB is. And then I want to take that string and I want to deserialize it, right, into my whatever my real type is, my desired type is, right? And I am telling Surde what that type is by annotating the actual variable that is receiving this match result, right? And then every other case that's possible, we already saw there's, message ping, message pong, message binary, but I don't care about any of those. So I just return empty. So this result set that's possible is, again, RPC response company, and then this specific SurrealDB specific error. Okay, so then again, we have a check, just like we did up here, right? Where we say, all right, so I attempted to do a deserialization, was this successful or not? If it was successful, then I'm going to get back the desired data, and I'm just going to return it inside of the sum variant because I'm returning an option. And then if it's not successful, I don't really care about, what the error is. Like, I'm not that interested, so I'm just going to return empty. Where is it? Yeah. So then that's what I have here. So then before I move to the next line, I think actually I didn't explain this, but we need to take a look at this because we need to understand the schema that comes back from SurrealDB. So then in this case, our return type is a generic type that takes any payload. So that's what this T is indicative of. So then this ID is actually the same ID that we passed in, that is unique for every call. So if we need to distinguish between various calls for whatever reason, we can base that on the ID. So then this RPC response has a result field, and the result field is of type vector, right? That contains potentially multiple surreal results that contain multiple vectors of whatever that payload type was. And a vector is just a dynamic array. So in other words, an array that can be resized. So why is this this result type, so complicated, right? So the reason why it's so complicated, and this is a sample JSON response from SurrealDB, is because, so first of all, we have that unique ID, is because every result can actually come from a request that had multiple query statements inside of it, right? So if we remember, our first query, it was actually two queries in one query, right? So that's why this is an array, right? So in addition to that, and I haven't found this myself of these results coming back as multiple, but there must be some particular type of query that can respond with, actually I know what, yeah. I haven't been using this, but because each query has the potential to give back multiple streams of data, right? Multiple rows, in other words. So that's what this is about. And then internal to that, you have an indication of whether even the query was successful and then how much time it took. So in other words, like metadata specific to the query. So that's why we have this structure here. We have an array of possible results due to the fact that we could trigger multiple queries. And then in each result, we could get back multiple rows of whatever the data is. So then come back here. In this case, we made a request to get company. So then that's why this looks like this. And then if we get back a response. As you saw, it's a bunch of nested arrays, right? So in our case, I know up front that there's only one company named Acme, right? So I just want to get the first one. So in the case of company, and of course, this whole logic is going to be specific to your data structure and your data needs. But I knew that at least for certain cases, I just wanted the first matching row. So that's why I'm having this get first function. And the way that it works is it has the root object itself. And then, of course, it has the first result field that's inside of it. Actually, I should have showed this. So we have this first result field inside of RPC response. So actually, Surreal result also has a result field. And then, the other metadata specific fields. So in the first case, this result is a collection, that vector, right? So dynamic arrays. So I'm iterating over it, meaning I'm doing next, give me the next one, give me the next one, give me the next one. And then in that making of this collection as iterable, I am actually running a function that iterates over it, right? So first I have to make it iterable, and then I can start iterating over it. So this find function is iterating over it, and the logic of it is take each piece of data and then make sure that the request was successful, and then get its own result field, because remember, Surreal result has a field called result, and RPC response also has a field called result. So get its own result field, make that iterable, and then see if any of those have a field named Acme, right? So give me that as a response, as an option. And then I'm going to unwrap that. I'm going to grab that thing that I unwrapped, right? Option, Surreal result. So I'm going to unwrap that. I'm going to grab that result field, and then I'm just going to take the first one, which is why you're seeing only one company. It's optional, but you're seeing only one company being returned. So if you're wondering what these, single quote A is about. So as I mentioned before, every Rust is memory. It does memory management for you via the parent scope of the owned memory of the reference type, right? So these lifetime indicators are specific to references. So in this case, I passed in a reference, and I am ultimately returning a reference from that reference. So whenever I do that, I need to indicate how long this reference is supposed to live that I'm returning, right? So in this case, because I got that reference ultimately from the parameter that I passed in, the lifetime of the thing that I'm returning has to be the equivalent lifetime, right? So that's what I'm indicating. That's what I'm indicating right here. All right. All right, so that was here. So I take my Acme Co. And the next thing that I'm going to do is I'm going to do a SQL update. So again, the SQL code that SurrealDB uses, despite being a JSON document store database, is virtually identical to just standard SQL with some fairly minor differences that are pretty easy to learn. So in this case, I'm updating my employee and I'm setting the company field to some argument called $co. And I'm selecting the specific employee that I want based on their last name, right? Now, the reason why this call is interesting is because you'll notice that when I created the employee, I never created a company field. So again, that dynamic nature of SurrealDB makes things just super convenient from a developer perspective to just get your work done and do your queries as you need and make changes to the schema as needed. So if we look at the arguments, again, it's a B tree of strings, and then we have the argument name and the fact that the last name has to be Franklin, and then the company name is coming from the Acme company, the one instance that we wanted, or the one row item that we wanted, and then its ID. So to be clear, I don't think I'm printing anything here, but the IDs that are in each table are structured as table name, colon, and then some unique ID. That unique ID, if you don't indicate it, is generally some sort of UUID, but it is possible to indicate that ID at the time of creation by doing something like this, if you want to. But if you want to just have a standard randomly generated ID of the UUID style, then you just don't put anything in there at all, and SurrealDB takes care of it for you. So then this UUID will become the value of company, right? And then we do exactly what we did before. We parse this return data. We try to get, our own object type for our own data model, in other words, that we constructed. And then because this is a very deeply nested set of arrays inside of arrays, we're just, in our case, we only want the first one. So we just want to grab the first one and go from there. After that, right, because I'm trying to do a test and I'm also trying to show as much variation in terms of all the possible querying types. After that, update, I want to, get back, or I want to select back that piece of data that I just updated. So the way that I want to do that in this case is I want to indicate that I want the guy whose last name is Franklin, and I am selecting. What am I selecting? I'm selecting the ID, the first name, the last name, and notice this guy right here, right? So this syntax indicates that this entity has a relationship with company, but the field, out of all the fields in company that I care about name, and then this data type has an alias of company. So then I'm indicating I'm coming from employee, and then, as I said before, of last name Franklin, and then I pass in those arguments, and I wait, and I get back the data. So if I run this test, let's make it pretty. See if if I have a... All right. So no capture is just that I want to be able to see the print line statements. So that's what that indicates. And then we don't want to wait for all the tests to run. So I'm just going to run this one specifically. And as you can see, we get our employee object back, or entity back. You can see the unique ID. It's the table name and then colon and then like a UUID. And we have the first name, last name, and then we have this come back. And the reason why it's an optional is because I might not have indicated a company when I inserted the data. So it acknowledges that and it gives me an optional. And the test is successful. All right, so that's it for this video. Kind of a long-winded video, I know, but it seems like some of the people watching the videos are not completely familiar with Rust. So we have these tests right here. Take a look at those. And then I have a bunch of examples specific to a particular query type. So take a look at those. I'll flesh these out more over time, but this is what I have thus far. I think that the way that this is structured is pretty simple and easy to follow, but certainly if you guys have suggestions, and especially if you guys want to maybe help me flesh out the rest of the the utility functions, whatever those may be, blah, blah, blah. I welcome any PRs that, you have time to submit. And that's it. Thanks for watching.